So my presentation is Algorithms are Recipes for Computer Programming. The foundation for this is basically algorithms make computer programming better, but a lot of people hear that word or hear anything math related and their brain just freezes up and they go, I can't do this, and they walk away before they even get very close to all the neat things you can do. And so I took it and said, well, what's comfortable and familiar? And for me, that's cooking. And I kind of mapped cooking onto algorithms and programming and threw this together a while ago, actually. So let's start with me. I am findable on LinkedIn. I work at the Multnomah County Library as a web developer. I have worked as a software engineer. I've programmed in Java, Haskell, Ruby, Python, PHP, Perl, C++, basically any language someone throws at me. I was programming in Golang for a little while. I don't care about languages. I like databases. I am an introvert. It isn't always very obvious, but I will be going home after this. There will be no party or drinking. I will be home. I like calling myself a cat lady. I only have 2 cats, but I feel like I still qualify because I like them excessively. I quilt, I knit, I bake. My mother did not expect me to grow up to be a computer programmer. I was trained to be a housewife. I'm not a housewife. I also watch mysteries, the British ones, and nice food shows on TV. And by nice food shows, I mean Chopped and Good Eats and the Great British Baking Show. I don't mean Hell's Kitchen. When you watch Chopped or Good Eats or the Great British Baking Show, you learn something about cooking. You might go away with some additional information. You watch Hell's Kitchen and all you learn is that it sucks to work in a kitchen. And that's too much like reality, working in a startup. You know, Hell's Kitchen startups, it's there, the cussing, the screaming, the throwing things, like those exist, but that's not the world I want to watch on TV. And I actually think that these map really well to programming too. Just like Hell's Kitchen is the place you don't want to work, these each exemplify things about programming. The Great British Baking Show is very much about how do you bake these traditional dishes? Good Eats is why, Chopped is what. So the Great British Baking Show, given an end result like a 7-layer cake, how do you make it again? Or Good Eats, given an end result like ice cream, then why do those ingredients combine like that? What Chopped is, given a box of ingredients, then what do you make that tastes good? That's reproducing, troubleshooting, and building from specs. And just like programmers, cooks fall into certain categories. You might be a recipe follower. You might be an experimentalist or a traditionalist. You might be really good at being an instructor. Professional cooks have certain personality traits. I'm actually married to a cook who just wants to be a line cook, flipping eggs all day long. No making menus, no ordering food, no figuring out what to do with the 20 pounds of peas that accidentally got delivered. That's a chef's job, you know. So these are all different ways of looking at what we do. And, you know, there's the perfect cook that you think that you can be, that you can't. There's the drunk cook that you really admire, but you probably shouldn't drink that much. The angry one, another drunk, Marcus Samuelson, you know, the one you have a crush on. But in the end, you just have to figure out what's closest to you and be the cook that you are. So, on to recipes and algorithms. There are big words definitions for things and little words definitions of things. So if we were going to go big words, it's a recipe is an implementation for accomplishing a goal, which given an initial state will terminate in a defined end state, or a set of instructions for making a dish. An algorithm is a deterministic automation for accomplishing a goal, which given an initial state will terminate in a defined end state. A set of instructions for solving a problem. when I first made this talk, I was like, cool, recipes are totally algorithms. But I talked to that one person in the office, and he was like, no. So really strictly, machine processed foods are the part where recipes and algorithms really overlap. But recipes themselves are just sort of tangent, just an aside. All right, so I make quiche. It's one of my quick and easy dishes. You basically take a cup of shredded cheese, you throw it in a pie crust, you take a cup of filling like frozen vegetables, you put that on top of the cheese, you beat 6 eggs with a cup of milk, you put in some spices, you throw it in the oven, it cooks. This is my quiche recipe. Very easy. Easiest thing on the planet. When you're looking at a recipe, you have ingredients, variables, your supplies and processes, like knowing how to stir or your spice cupboard, those are your libraries. Your kitchen could be an operating system or your server. You know, it can be a mess or it could be really neat and clean, just like a server. Instructions, procedures, mistakes, errors, return variables, or dishes. So it all maps really well. This is an example algorithm of a quiche written as a function. We're importing the libraries for time, oven, utensils, bowls. There's a function, make quiche. You put a whole bunch of things into that function. You set the oven. The quiche list starts by putting the crust and the cheese, and then for each item in the bar filling array, you loop through and you put those fillings in. You have wet ingredients, which I include seasoning in wet ingredients, which is just sort of this baking thing. And then, you know, you add the wet ingredients to your quiche list, and then while the fork comes out wet, don't do anything. When it's done, put it on the counter, sleep for 5 minutes to cool, cut, and you have a quiche. So that's an algorithm. Really quick and dirty code example of taking something that you do and turning it into code. Now you can do this with anything you're familiar with, and it's a really fun exercise. Like if you're good at something, try writing software that just sillily takes the words that you put in and returns the things, and see if you can't code those familiar things. I've done it with how I interact with people, and I burned that disk. Like, there are some things you don't want other people to know about you, like how you actually choose friends or decide to return phone calls. So calling the quiche function, my quiche, I call with Swiss and store-bought frozen crust, and I put in garlic and spinach, artichokes and chicken, which has been pre-cooked, and free-range eggs, and milk, basil, salt. That's my quiche. What makes it an algorithm is that I can make any sorts of different quiches. This is Isaiah's quiche. There's no meat in it. Rice milk, lactose intolerant. This is my father's quiche. He has heart problems. He does egg substitutes, coconut milks, Mrs. Dash. So there's a lot of variety. If I just gave you a hard and fast recipe, you have to use a cup of cheddar cheese only, and it has to be Tillamook cheddar. That's not an algorithm. That's procedural. That's just like steps that you follow. But as soon as you generalize it, as soon as you make it into something that you can sort of mix up and still get good results at the end, that's where you're hitting algorithm territory. Let's go back to my algorithm, because one of the most important things you can do when you're writing algorithms is knowing how to critique them. So I walked through this, and I'm not sure if you noticed when I was talking earlier, I said a whole lot of words that were not in this program. Can any of you spot like horrifyingly bad ideas in this? There's one that just drives me crazy. Anyone want to? Come on, criticize. Yeah, go for it.
You don't have an action for beating the eggs and milk.
Yes, there's no mixing the eggs and milk. I'm going to have like 2 hard-boiled eggs floating inside of milk. you know? There are a lot of little detail things that have been left out. There are no checks on quantity. There are not enough errors. But what really gets me, besides not being used to microphones, is this while. So I put the quiche in the oven, which again is just assumed. Nothing about that. I'm running a while continuously the entire time that this function is going. That's like opening the oven every 5 minutes to see if the quiche is ready. The order of magnitude on this, which I'm not going to go too much into order of magnitude, but order of magnitude in algorithms is when your quiche doesn't bake because you're opening the door constantly. It's when your server crashes because you're calling a thread and you're tapping, instead of calling a thread, you're tapping a file to see if it's been updated, It would be much better to say we can assume that my oven will cook for 20 minutes before I have to check it, and then I should only check every 5. Or maybe make it so that I import a nose library and I can smell when it's close to done, And that way there's feedback. But this is the sort of, here I'll add those. I also didn't preheat the oven. And there's no function around taking things out of the oven. The first run when you do something is never the correct answer. Like your first function is only a first draft because there is always going to be something that you haven't taken into account or that you just glossed over. Oh yeah, you always put on oven mitts before you take hot things out of the oven. Yeah, everybody knows that. And we make a lot of those assumptions around computers. Oh, the database is always available. It's just grab the stuff out of the database. I don't need to check to see if it's up or if the data is being returned or if it's returning a lot more than I expected. This is going a lot faster than I expected. So this gets us to what sorts of algorithms are there. I mean, I talk about algorithms as being basically anything. There is, of course, on Wikipedia, a list of algorithms. You use algorithms to sort, compare, find, map, check, create, sift, change, combine. I really like playing with data. And let's say, for example, I don't know if any of you went to the Wayback talk where the person was talking about the Wayback site and how it has an API and you can call information. So let's say that you've been maintaining Intel's site for like 10 years and you want to have some sort of changes over time record from the API. And you want to compare that to another site, IBM site changes over time so that you can say, oh, well, the 10 years that I worked at Intel, the site was like this and it changed this often. And if you compare it to IBM site, you can see that it changed this often. So there's an API on the Wayback Machine. And you can say, give me information about this URL. So I can look up the site I built in 1999. And I can say this is what it looked like and these were the changes that occurred and how often changes happened. Now imagine harvesting that data. But you have to have an algorithm of some sort. You have to have some way of comparing that information. The example I'm going to use in this, when you use algorithms, I think always. Like obviously I wrote an algorithm for how I interact with people. If you have a flow chart, if it's like consistent and reliable and repeatable, it can be an algorithm. But just as an example, let's say you have 2 arrays of dictionaries of user data, one from Facebook and one from LinkedIn, and you want to know which site has more user data. The desired result is a dictionary full of users' emails and then a value, either Facebook or LinkedIn has more user data for this. So you run through a whole bunch of users and you compare. And this is possible. So on Facebook, you can see I've put in my email and my username. I skipped age and gender. I put in a marital status. Whether or not it's true or not, nobody knows. It's Facebook. I have relatives, favorite color, car type, and my favorite curse word is darn, which that's shout out to all the knitters. Yeah, okay. And then up here on LinkedIn, again, email, username, employment status, where I work at the library. I went to University of Oregon. My high school was South Eugene. I've got one relative on that site, and I didn't put in any personal information at all. So there's this desire to look at those two lists and say, well, I can just get a list. Like if there are 5 items on this side and 6 on that, then the one with 6 has more information. What it doesn't take into account is the arrays. So as soon as you add arrays, yes, I am pointing in the right direction. Okay. As soon as you add arrays of data, as soon as you say, well, how many relatives did she list on Facebook versus LinkedIn, then you're recursing through and you have a lot more information to count. And as soon as you have something like that, you can't just check the length of the dictionary being returned. You have to say, okay, for this dictionary, I have to go through and look at all the text options, but then if there's an array, I'm going to have to recurse through that and find out how many variables are available in that. Like, how much information is there really? And with that, you'd find out that Facebook does actually have more. This was actually something I did at a job. I went through dictionaries of data available on social media, and I compared it and sometimes merged it and sometimes updated it. It was interesting, and I did use Python because Python's awesome for that. Algorithms are also awesome. So if you have something that's repetitive, flexible, or recursive, you want an algorithm. You should look around and see what's out there. Like, just read up on sorting algorithms, if nothing else. Like, it seems like so many of these things are done for us. Like, I want this list to be alphabetical. But if you learn about how that alphabetizing works, then you can apply it when you have to write your own recursive functions. Because there are concepts embedded in the algorithms that are really helpful. So, repetitive, if you want something again and again and again. Flexible, if you want to do many different things with one. And recursive, a lot of veggies. I know this is a really huge chunk of text, but I really do think that being able to accept failure is the most important thing. You have to write that crappy first draft. You have to write the function that doesn't catch every error, that doesn't remember to put the oven mitts on. You have to be willing to fail, because failure is the only way to move forward. And I love this quote, which also has a quote embedded in it. So I'm going to, I don't know. Yeah, I'm going to go ahead and read through it since I've been talking fast and yeah. So the first requirement for programming is a passion for the work, a deep need to probe the mysterious space between human thoughts and what a machine can understand, between human desires and how machines might satisfy them. So that part for me is computers do exactly what you tell it to. And isn't that just crazy? Like, really crazy, wonderful. But then you get into, what are you actually telling the computer to do? And what have other people told the computer to do? And where does that conflict? The second requirement is a high tolerance for failure. Programming is the art of algorithm design and the craft of debugging errant code. In the words of the great John Backus, inventor of the Fortran programming language, you need the willingness to fail all the time. You have to generate many ideas, and then you have to work very hard only to discover that they don't work. And you keep doing that over and over until you find the one that does work. And it's really just, you look at programmers who stick with it, programmers who've been in the business for a long time, and it's a combination of those two things. One is that you have to be really interested in like just exploring and being creative, but the other is that you have to be highly fault tolerant. I've been, 1999, I've been programming for a little while, and if I freaked out every time I failed, I wouldn't be here. I would be a project manager. So, this is actually one of my personal failures. This is just a complete mess. This is me attempting to make a smoothie, and there's no recovering from this. You can't even it's just gone. It's all gone. You just don't even clean it up. You walk to the pub down the street. You order some nachos. You say, oh well, oh well. There's also the sort of failure that I like to call the last minute fix. This is a trifle. The story goes, the myth around a trifle is, someone was making a cake for a dinner party, and the cake fell apart, and the dinner party guests were about to get there. Oh no, the cake was falling apart. And the cook, took the cake and put the pieces in this really beautiful dish and layered it with fruit and whipped cream, and they turned what was a totally crumbled disaster of a cake into a new dessert. So you can have a total crumbly disaster of a function, but still recover it well enough to feed to your guests. It doesn't keep well in the refrigerator, though. There's also methodical breaking. This is the Good Eat style. The last one was Great British Baking Show. Methodical breaking is when you go through and you try to figure out what the result is going to be if you change something. So to me, melted butter and more flour are total failures of cookies. Those are the ones that should not exist. But melted butter is way too crunchy, like it breaks, and more flour is just like the big poof. But that one's in between, you're experimenting to see what your oven and what your ingredients and like all these different techniques will do. And that's why it's really interesting to try to do things again. I've written a ridiculous number of importing Excel spreadsheets into databases functions in a variety of different languages. And it's really interesting to try those different languages, to see which language you like the best, to have one of those like basic-ish problems. But how do you attack it? How many functions do you use? Are you going to try object-oriented? I would really recommend just sort of experimenting, choosing one thing, like chocolate chip cookies, except for maybe a red black tree sort, and just doing it in 3 or 4 different languages, doing it in all different ways, and just see how they all different work. And maybe even put a timer on them and be like, wow, this one only took 5 seconds. I have a friend who really likes to do that a little too much. Timers, obviously. Yeah. And then there's also just trying something different. This is a strawberry and asparagus quiche. I still haven't tried to make it. It's one of those ones that you read it and you're like, strawberries and asparagus. Yeah, it's like a friend of mine who told me that avocado belongs in a milkshake. I still haven't tried it. I know that it's done, and it's really done, but I still haven't tried it because I'm a little nervous. But sometimes you have to try. Yeah, it's the original avocado is a fruit. It's supposed to be in desserts. My habit of putting it on burgers is profane. But anyway, that's not the point. The point is that Failure is about embracing things that you're uncomfortable with. And so you might think, I don't know if I could actually import an Excel spreadsheet and have it come into a database in a normalized fashion. This seems a bit weird and outside of my comfort zone. Just try it, you know? You probably can. And I'm pretty sure I'm way under. We're going with the last talk of the day and early. That's basically it. The bit.ly link is to the Google Doc that I made this with. I know a lot of people uploaded theirs. I just share the Google Doc. My main goal was to give you some ideas about being more comfortable and having fun. Are there any questions? I have a wide range of knowledge. We could go any direction here. Yeah.
Do you know of any tool that you give it the ingredients? I open my fridge and pick all the items that are about to expire.
Yeah. So there's a site called Epicurious.
Okay.
I'll just put it on the slide. Epicurious.com. And then we'll go back to presenting. Yeah.
IBM Watson also has one.
IBM Watson?
Yeah, there's an IBM Watson has something that's like, here's the ingredients I have, and then it will just give you.
IBM Watson, isn't this for chess?
It also does like medical diagnoses, and it's a kind of complex little piece of work.
So yeah, Epicurious is actually, it's a combination of several recipe magazines website. So Bon Appetit and a lot of other magazines for foodies all put their recipes on the website, and you can say, I want carrots to be my main ingredients, and I want it to be a vegetarian dish. And you can sort, it's got ratings, some pretty good food up there.
Do they have APIs?
They don't have an API. If you want the API option, I'd suspect IBM Watson. I haven't messed with Watson.
Yeah, I don't know if Watson has an API, but I suspect if it does, you might have to pay for it.
Yeah.
It has a lot of free options, but I haven't heard of its recipe options. I've used it for Twitter's sentiment analysis.
Yeah, it has a special website just for the recipe options. UI.
But maybe that's the thing you build.
Yeah, okay.
Get in touch with Epicurious. Be like, I can make an API, and then people can like.
Yes, please.
I have an application to whatever I can pronounce it. What do you mean about like signing up and like?
Signing up isn't that bad. I've got a recipe box on there. There's a pot roast that wins every family dinner. And it's saved forever because I signed up. Yeah.
So going on the intentionally making mistakes kind of idea, Netflix has done a lot of intentional mistakes kind of research work to see how stable the system is. It seems like what we see good.
Yeah, good testing also. A lot of people, when they test their software, they look for what they expect to work, but testing for not what you expected. So, you know, is the cookie too hot? Is it going to burn someone? Like, you have to test for the awful outcomes as well. So, definitely. Yeah?
All of the programming languages you use, how do you keep them straight when you're moving from one to the other? It's so hard to remember. How do I start with this one? How do I start with that one? How do I start with that one?
So, there's a couple of weeks of why is it angry every time I make a semicolon? But then you just get used to it. I tend to program whatever work requires and mostly stick to one or two languages at a time. Though there was a place that I worked at that literally had Scala, Haskell, Ruby, PHP, Python, and a hidden C library. You think you know that place, Joe? Yeah, so basically a good IDE is really helpful, like something that highlights. And if you're really color oriented, if you can even have like, I'm going to use nothing but black background with Python and nothing but white background with Java, because it just helps you realign quicker. So, yeah. Anyone else? Yeah. Cool.